All right. So in this class that we are going to be having, we are going to actually concentrate on our graphs, the part of our graphs, as we have discussed before about this term. If you have managed to go through the video that I explained about the topics that you're actually supposed to be working with in this term, and also your preparations of all the topics that we had from term 1 up to term 4. So make sure that you do that. And with this part of our graph, there's nothing that you actually need much. They just want you to go through this, the interpreting of graphs. You have removed a lot of things, just one or two things that have been removed from our graphs. So we are not going to be focusing with the old syllabus as we used to have. This time, we are going to be focusing with the interpreting of graphs. That is, analyze, interpret global graphs of problem solving with the special focus on the following trends and features: linear or non-linear, constant, increasing, decrease. They want you to interpret these, the understanding of these. Interpret. Then we're going to talk of what? Drawing of the graphs now. So we're going to say that part in another class. But for now, on the interpretation that we saw, or on those terms that we are seeing, I'm going to just try by all means to explain one or two things that you need as you are to answer your questions, as you are to interpret your graphs. So we're just going to have, in this case, that is interpreting. All right, so let us just have interpreting graphs, which is the global graphs. What is it that you are actually referring to? What is it that you are supposed to talk about? We saw from that, we are supposed to be talking about the terms in terms of being maximum, in terms of being minimum, constant. So these are the ones that you're going to, okay. So let's start with this part of being linear or non-linear. What is it that you are supposed to consider there when you are to interpret a graph? A graph is being linear, or we are referring to a condition which is non-linear. All right. From the linear graph, if a graph is being drawn, and we are saying this is a linear, it is the one which forms a straight line. That is a straight line. Whether it is of this nature, whether it is of whatever as long it is a straight line graph. Whereas non-linear, from the non, not, it is not linear. It is not. So if we have a straight line like this, and we are saying something is not a straight line, then how is it if it is not a straight line? It is in the form of a curve. It is no longer a straight line. It is in the form of a curve. It can be this way. It can be this way. It's no longer linear. It's no longer a straight line. It's now a curve. So that is the condition that you will need to just understand between these two. All right. So let me just write this part that I was explaining. So I said the linear. All right. So starting with the linear function, or the linear graph, these ones, they tend to follow a straight line. All right. So tends to follow a straight line. A straight line. So when you are drawing this, it is going to follow a straight line, which means that's simply a straight line pattern in terms of the presentation of the numbers that you are having. So the graph is simply what? A straight line graph. So we are simply talking of a straight line graph. A straight line graph. a straight line. So it can be in this way, it's going to be this, it can be this, whatever that you have, it's a straight line. We are not focusing of being increasing or decreasing. We just a straight line. We're going to talk of those terms later on. The non-linear, it's not linear. So if it is not a straight line, it is what? It is a curved graph. So in this case, we are going to have the graph is curved. It's no longer a straight line like what if you're going to have any sort of a graph as long it is curved, not straight. As long it is a curve like that, you refer it as non-linear, not opposite, the opposite of being linear, opposite. So that is the condition they are talking about. So when you are interpreting, a line is drawn, they're asking you, what type of a line, what type of a graph is that? You can see from the presentation of being a straight line or being a curve. When it is a curved like this, then it is non-linear. When you see a straight line, it is a whatever that presentation that you're going to have there on the graph or something that is presented. They draw something like this. They want you to tell what type of a graph is that. That's a linear. But if there is something that is being drawn like this, we cannot say this is linear. No, this is now non-linear. It can be like this. It is non-linear. It can be like this, non-linear also. Interpret, to tell. Can you tell? You are not doing anything for now. We are just telling us to say what type, what are we having. Then there are these terms, constant, increasing, and decreasing. These terms are best to describe when we are having these graphs now. You have the graph, so you want to tell what is happening on the graph that you are given. So when you are given this, let's just consider this way. You know, the steepness of the slope. Considering this line, we can see that we are increasing, we are going up. It is on the rate of change of the y and the x values. The rate of change, like if you consider, let's say, we have got a y value and we also have an x value. The rate of change that is happening between these two values, the rate of change is like how the values are changing from one point to another, from one point to another. It is going to be a positive change, this one. We are going to obtain a positive change, which is the part that is best explained in your grade 9 mathematics. For now, guys, let us just know that these lines which are like this, going up like this, they are increasing positive gradient, a positive change. When a line is facing down like this, it's what? A decrease is going down like this. They are facing these ones. They are facing this way. They are decreasing. All right. So when it is not increasing, when it is not decreasing, it means it is what? A constant, which is something like this, horizontal like that. There's no increase like what it used to be like this, or a decrease going down like that. This one, it's constant. The values are the same throughout, like what we are seeing. It's a horizontal line. When you see that, that's a constant. If we explain these terms on a non-linear type of a graph, where there is a curve like this, and let's say there are points, let's say from this point up to this is the turning point, which is best described when we are to compare maximum or minimum. That type of a graph, it consists of what is called maximum and minimum values. But I'm not going to focus on that for now. I'm focusing on the increase part. So the increase is going up. As we can see on our graph, going this side here, we are going where? Up to this point here, where it is now straight, linear, which is, where it is constant there. So if you are going up, that's an increase that you're having here on this type of a graph. You reach a certain point where you say it's what? It's not moving. There's no movement. There's nothing there. Then what's going to happen? You're starting to go down. It's just like the issue of climbing a mountain. You are going to the peak of the mountain. You are going to the top of the mountain. What else do you expect to do? To go down. So going down, it's a decrease. That is the concept. It's a decrease, which is opposed with this type of a graph. When it is like this, let's try to figure out what is happening on this one. We can just consider what can we use in this case? Anything, just something that is going down. It's no longer like a mountain concept. Let's say those, if you consider there are those actually those games activities that we used to play, when you can even be like going down, then it's going up, going like this. You still remember those concepts. So the concept is you will be going down like this. You're going where? Down to a certain point where now you're only left to go up. So the going down, a decrease, okay? Because you're going down. Going up, an increase. This is the concept of an increase and a decrease of the graphs. When it is not linear, like you can interpret it that way. For being a linear, we said everything like this. It's what? Your increase. That's an increase. When it is going like this, that's a decrease. So you're going to consider that as a decrease. A horizontal line, constant. That's being constant. So I just hope there is, with these, you can tell there is no need for me like to write anything to say increase is going to be rate of change, which is positive. A decrease rate of change, which is negative. It's best for you to just understand this way. Much about this is best explained, like I said, in your grade 9. For now, I just want you to know the basics. So that is it, guys, about being constant, increasing or decreasing. Then we move on to the maximum or minimum. When we say the graph is at its maximum, where is it? This is like I was giving the example of climbing a mountain, going to the top. Then you start to go down. What was it? When you are here, where are you? Where are you situated there? You are standing or you are on the top of the mountain, the top, that is the maximum. So anything that is of this shape, it has a maximum value at the top there. This is where you have the maximum value here. That's where you have the maximum. The graph is said to be maximum at that point. Then it starts to go down. Like so it was increasing, it reaches the maximum, then what happens? It starts to go down. The opposite, when it is like this, what is happening? It's a decrease until where this value is called the minimum. That is how deep we can go, minimum. The deeper part, like just like the concept of a sea, okay? Or what can we talk of those sea level concept? The sea, the bottom of it is the minimum. When you talk of a mountain, the top of the mountain, maximum. So that is how you can simply have this. So this one is referred to as the minimum here at this end there. It will be your minimum value that you're going to have there. That's our minimum. So we talked of these terms, maximum, minimum. So on a straight line, there's nothing like there's nothing. We say the rate of change there is the same. We are not having maximum. A maximum is considered when there's a curve. That is where you think of maximum or minimum, not on a straight line, not on a linear function. On a linear function, just think about these: increase, a decrease, and a constant. That is what you're supposed to just think of. A non-linear, think of an increase also, maximum, going down, a decrease, minimum, then increase going up. So I want you to revise these basics. If you just find time, you can just analyze, guys, what is happening, because they're going to be focusing on this. They're going to be having repetitions there. Then we have got the major part of being discrete or continuous. They want you to interpret these terms in terms of your graphs. You have these graphs now, which can be linear, as we had, which can be non-linear. But when interpreting about being discrete or continuous, what is it that we are saying there? All right, let's start with the part of being discrete. Information or discrete data, the data when it is just being given. What is it that we are considering there? We are just analyzing. We are not going to be into much of that. Just analyzing what is it. This is the type of information or the type of data which is, or that can be counted. It is information that can be counted, data that can be counted, right? So this one is data that can be counted, that can be counted, or that is counted in short. Let's just say is counted. Okay, what are we trying to say? When information is being counted. Let's talk of just an example of you guys. You are at a school in your grade 8, then you're in a class. When the teacher is asking you how many students or how many learners are here in class, how many learners in a class? I want you to understand this. You are in a class and you are being asked how many learners are there. How are you going to answer the question? You are going to count each learner inside class. 1, 2, 3, until the end. You are counting. So, meaning to say, when you are counting the number, you cannot give an answer like this. There are 20,3 people, or there are 20,3 students. No, it cannot work like that. Counting, these are all numbers. When you are counting, we count 1, 2, counting values 1, 2, 3, counting numbers 1, 2, 3, 4, 5. There is no decimal there. There is no 1,2. There is no 1,3. How many cups are you having in your kitchen? You count them 1, 2, 3. You cannot say I have got 2,3 cups. No. I have 3 cups. I have 4 cups. This is the type of information called discrete. You count it one by one. So as we can tell from the counting part that there are no decimals there. So thus only whole numbers are used. Talking of what? Counting numbers. Talk of only whole numbers there are used. counting numbers. For an example, we talked of how many students that are in a class. How many cups are you having in your kitchen? Anything that has to do with counting. You are waiting at a certain place where maybe it's a parking place. Then you're asked, how many cars are there? You have to count. One, one, one. How many cars are there? That type of information is one that you call discrete. You count it. So in terms of the presentation, here we are talking of interpreting it. How are we going to interpret? Dots are used in terms of presentation now. Dots are used when representing this information. When representing data. When representing this information, this data that we are talking about, when they represent the discrete information, they are going to use dots. They're going to use dots. Let's say if there's an information that you are given, then they'll be just using dots. Another one, another one, another one, another one. So they can just, okay, something like this. We are working with the dots from one point to another, discrete. So for now, I'm focusing on being counted information. All right. Let's talk of the continuous as we close up so that we can check the examples that we are having. How can we, or which type of information do you consider to be continuous? Which type of information is this that you have to consider to be continuous? This information is the one that can only be measured. Is data that is what? Measured. That is measured. To measure and to count, these are two different things, guys. When you measure, you are not counting. You are giving like a dimension. Maybe you're talking of a length. You're asked to measure from point A to point B. You take a meter ruler. On measuring, whole numbers can be found. On measuring, whole numbers can be found. On measuring, decimals can also be found. Decimal numbers can be found also. So this is the type of information where decimals are there, whole numbers also are there. Yet only we do not have decimals here on discrete, but continuous. We can talk of whole numbers. We can talk of, so decimals can be used. Anything that you can measure, is it weight? You can measure weight, the mass, length. These things can be measured. That's continuous information. Talk of the height. There's so many things that you can measure. Not counted. Not counted. So in this case, we expect to have whole numbers and also to have decimals. Decimals can be used in this type of information. Decimals can be used. I did not say decimal only. I say can be used, meaning to say they can be part of your answers as you have whole numbers. Here, I use the word only, meaning to say there is nothing but only whole numbers that we need. Be careful on that one. When you are given, in this case, all right, this is H there. When you are given the presentation now, you are going to represent this using solid straight line, or a curve is used to join the dots. We have a solid. Remember there we had the condition of these dots that you had, that you plotted, and you just join from one point to another. Sometimes they even don't even use this present. They just put the points, this one and this one. But when you consider now continuous, the points that you are going to mark, or the dots that you are going to mark, let's say there's a point here, there's a point, there's a point, there's a point. These are joined straight line from one point to another. Solid continuous line is used. A continuous line is used as you present continuous data. You use a continuous line. The line is not supposed to be the broken, the dotted one like what we had. No, continuous. All right. So we are going to see that. But for now, let's try to answer these questions pertaining the two that we just discussed, the discrete and the continuous, because these ones, as you can see, guys, they are direct. You consider being linear, this and that. It's just going to be the same way that I'm presenting here. They're going to give you the graphs in the same way. So you just have to interpret this way. But for the discrete and the continuous, you just have to be very careful with information, how it is given. Like on this question, they are saying on number one, which of the items in the list provided can you count? Can you count? And which quantities need to be measured? Which part that you need to measure? Which part that you need to count? So we said measured, continuous, counted, discrete. So yeah, they just want you to know which one can you measure, like on these ones. All right. So here, copy the following table and write your answers in it. So in this case, what I'm just going to do, I'm going to just list in terms of A, B, then, but as we were supposed to write, like if A is the number of cement bags, you write that. But here, I'm just going to write the letter corresponding, then you know what is representing there. All right, let's start with A. The number of cement bags sold. Sold, the number of cement bags sold in a shop. You're in a shop. You're in a shop. You see the number of cement bags. Do you measure them or you count them? That is the question. You count 1, 2, 3, like how many bags are there? So this can only be counted. You cannot measure. You don't measure the number of bags to say there are 20,2 bags. No, you count them. If they are 20, they are 20. So it's a counted one. So A was going to fall under the part that is to be counted. We have got A there. So like I said, you are supposed to write the way that it is, number of cement bags sold. But here I'm just going to tell you that it's A. All right, let's move on to B. Where is it going to follow? Which is the heights of learners in grade 8. The heights. I talked about this guy's height. You measure. Height, length, mass. It's measured. So B, representing the height there, is supposed to be what? Can only be measured. So that part there of the heights is supposed to be measured. Okay? Let's check C. The time taken for athletes to complete 400 meters hurdles race during the Olympic game, the time, you measure it. All right? When talk of time, it is measured. All this part of what? Of measurement, time. You cannot count, but you have to measure those times. So C is part of what? Can only be measured, time. So you're going to write the answer there as it is. But here, guys, I just want you to have it like that so that we do not spend time. I never thought it's going to be this long. All right. Anyways, let's see. D, the number of sweets in various 500 gram bags. The number, how many, like the sweets inside. Okay? There are a number of sweets there. Another bag, it has number. Can you measure these or you count? You count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is how you do it. So this can be counted. So this is D. We are going to write it under. Counted can only be counted. So D was going to follow under this. So, but for you guys, you are writing the answer here as it is. You are writing the number of sweets. Here, where I'm writing D, you write the answer, the number of. Okay? I hope you understand what I'm trying to say there because of time. E, the distance traveled by learners to school. Can you count the distance? Is it possible when you are from your place going to school? Are you counting distance or you measure? The distance is measured. Distance is same as this part of length. As you measure length, as you measure height, you also measure distance. It's part of those that can, so many things, guys. So this can be measured. So E, which is our distance, whatever that we have there, was or can only be measured. All right. So E can only be measured. Let's move on to another part. If we check, there is F. Cars passing at a scholar patrol crossing. Like I was saying before, you are counting, maybe you are at a car park. Then you are asked, how many cars are you seeing? You have to count. You cannot measure the cars. You count them. 1, 2, 3 there. There is 1 car, another car, 2, 3 cars, 4 cars, 5 cars. You count them. So it's by counting the cars. That's F. So F there, you're going to write it under. Can only be counted. You cannot measure that. The cost of an exercise book in rands and cents, the cost is under measure. If you talk of cost, you put it under measure because there are decimals there, rand and cents. It is 1,23. We don't have decimals, remember, on things that are counted. No, just whole numbers. There are 2 people, there are 3. But if the question was asking you about the number now, the exercise, like the number of the exercise books, then if I'm saying, let's say the question was like that, how were you going to answer it? If the question was asking you about the number of exercise books, that one can be counted. But here they're not asking you about these books, no. They're asking you about the cost, the money in rands and cents, 1,25. Decimals, that's being measured. Remember, under measurement, we say decimals can be there also. Decimals can be used. So that is what? H. So H can be measured. All right. Let's move on to the last part, which is the temperature. You are asked to bring a record of your temperature. Are you going to count your temperature? 1, 2, 3? No, you cannot count your temperature. You measure it. That's why you've got instruments which are used to measure temperature, not to count the temperature. No, they measure it. So temperature is measured. So H was under measured. That's why temperature, it can be at 20,3 degrees Celsius. It can be at 21 as a whole number. It can be a decimal. So that's being measured. Decimals are also accommodated. But in counting, we don't accommodate whole numbers. No. When counting, it's whole numbers only, no decimals. No decimals, no. All right? So this is what you're supposed to have. These are the answers that we're supposed to be undercounted. Answers that are under can be measured. Then let's just see the last part to analyze, interpret this. Say if the following makes sense or not. Explain. Does a statement that you're given there make sense? All right, let's start with this first one. 501,3 learners. Before I even finish this statement alone, before even I finish this part does not make sense here. This part it doesn't make sense. 501,3, 501. Is that possible, guys? We talked about that. Learners. Can we have a decimal when counting people? The number of learners, remember, they're counted. So this does not make sense. It cannot be like that. It's supposed to be a whole number, discrete information that you talk about there. So this one doesn't make sense, this one. Okay, does not make sense. Okay, so the reason is that discrete information cannot have decimals. We talked of what? The discrete information. Thus, discrete information or discrete data cannot have decimals. Or when counting, we cannot have decimals. That's it. When counting, we cannot have decimals. That's explained part. B, the distance from school to the nearest shopping mall is 10,75 kilometers. Does that part make sense? Yes, it makes sense. We are not about this thing of being nearest or what. It's just like the distance. The way it is presented, does it make sense? Yes, distance can be a whole number. Distance can be a decimal. It's a measured value. Distance is measured. So this one, it does make sense. Okay, so it does make sense. Okay, so in this case, we talked of what? Distance can be measured. Okay, distance can be what? Can be measured. Distance is measured. Therefore, can be a decimal. Therefore, it can be a decimal. It can be a decimal. If something is measured, decimals are accommodated, like I said before. Let's move on to another part, which is the last question of this, which is C. You are given 2004,75 cans of cola were sold during a fundraising event. Before we even finish this, does it make sense to say we are saying 2004,75 cans? The number of cans of cola. The number of cans of cola. They are being counted, isn't it? You count them 1, 2, 3, 4, 5. So when counting, do we expect a decimal? No. No. It's impossible. So this does not make sense at all. The reason, you just put the same reason as you had on A, because you said A does not make sense because it is counted, not measured. In counting, there are no decimals. In counting, there are only whole numbers. So this is it, guys, on interpreting of these graphs. I want you to revise as much as you can as we are going to move on to another part of the presentation, representing this information. Actually, we're going to focus with the issue of the straight lines, next class, the points, and so on. So just make sure you become part of the family if you are new to this channel, so that you become part of the family of Maths on African Motives. Till we meet again.